Okay. Hello? Okay. Okay, guys. Yeah, okay. So this second part actually is not going to be so technical like the first part. So we're not going to do any of those command line stuff anymore. This part, basically, I'm going to introduce you to Docker Hub, which is, okay, so let me show you next slide. It's a bit like GitHub, but it's for container images. So just now I keep talking about, the repository. Every time you press run, it's going to pull from somewhere, right? So this is basically where it all comes from. It's like GitHub, except for container images. So let me show you Docker Hub and what it looks like. Yeah, so this is one of the good things about using Docker. There's the community behind it, which is important. So you have all of these pre-made images, which you can already get. As you can see, Nginx, probably because everyone uses it to host websites, is like the most pulled of all. It has like 10 million plus. This is like a #1 container. Of course, you have other things. Yeah, there's an Ubuntu container, which is interesting. Like you would think, how can you be running an OS within the container, right? But okay, I'll leave you all to go figure out the technicalities of that one. Basically, the kernel is probably still the same, but it's sort of running a different OS. So actually, you can have, even if you're not running Ubuntu on your host OS, you can have Ubuntu within the container. Okay, so you can use this basically as like a base container lah. If you just want to install things like you normally would on Ubuntu, you can install Ubuntu, and then install Docker, and then run another container within a container, and so on and so forth. Recursively run container. You can technically do that. Just I don't know why you want to, but yeah, technically you could. Okay, yeah, of course you have all your MySQL, Mongo, Postgres. That's the one that we pulled just now. This one is actually from a Docker tutorial. So hello world. That's probably also why it's one of the most pulled. Node.js. You need this for Meteor, but I don't think this is not the Meteor one. But yeah, Node.js, Docker Swarm, HTTPD, I think. Can't remember what that is. So on and so forth. So you have Golang, Java. Yeah, so yeah, just now we also use this one, Python. So if let's say we click on one of these, right, usually they will give you some instructions on how to deploy these containers. You can just follow these instructions. Yeah, so the second example just now, you remember how to build a container. Actually, it came from here. So this is how you build a container for a Python application. For different application, for different kinds of different base. Like, okay, if you're using like Express.js, you can go and find one for that. They probably have a different set of instructions as well. Should be a similar idea, but basically, yeah, maybe it's a bit different. You can try it. Now, of course, you have all of these. They normally just give you instructions. So yeah, actually, Docker, you don't have to, exactly remember all the commands. Ideally, you should be able to roughly understand what it's trying to do lah. So in case you want to do a bit of debugging in case something goes wrong, or you want to have a bit more flexibility to change what the directory is doing, at the very least, you should be able to understand what these commands are doing. So yeah. So that's Docker Hub. But of course, you can have more containers which are doing other things. Hold on. Well. Okay, so yeah, these are just like the basic containers. But of course, you can have other containers, which are basically other developers who are shipping their own applications. They are also on Docker Hub. So I just have a few examples of some interesting ones over here. Yeah, so I mean, it's not uncommon if you go to GitHub nowadays. Sometimes you will see that container tell you, okay, so you want to deploy this server software, this is Docker container deploy, use these commands. So yeah, I mean, Docker really makes things a lot more convenient, because last time when you want to do this sort of thing, right, if let's say you have some server application that you want to deploy, the instructions are going to be like, oh, okay, you need to install this dependency, install Node.js, make sure it's the right version, then install all of these other libraries, and then finally install the download the GitHub, and then blah blah blah. So it's a very, very long process. But when you have a Docker container, because everything is just one box, so all you need to do is Docker run and some stuff, then it will run the entire application for you. There's some examples of some of the things that you can get hold of with in a Docker container. I actually use this personally. This is Jupyter. Anyone heard of Jupyter? So Jupyter basically is like an interactive code notebook sort of thing for Python. Mostly for Python. You can get it in other languages, for R and Julia as well. But basically, I find this very good, because for me, I'm a business analytics major, right? So I have to sometimes do all this kind of like data science homework and stuff like that. And normally, when you're doing data science, I mean, in software engineering, normally when you submit the final application, you want to hide away all your code, right? But when you're doing data science, usually the code and the trace back as to what exactly you did to the data is all very important. And of course, Jupyter also allows you to draw graphs completely in line. So it's not like, if you normally draw in Python, it's like you write the code somewhere, and then your graphs and your graphics and whatever, it's all going to appear in another window somewhere. So here it's all inline. It's just going to appear in the same place. I actually have this deployed on my own server, so I can show you this. Just it's a very good application that you can try next time if you need to work with any data. Nice. Yes, this is my own server. So, so basically, if let's say, for example, this is actually my internship project. So, yeah. So, yeah, you basically can write all the code, and then you can just run it within here. And then if let's say you need to draw any graphics, right? Like let's say you need a map. I think it's a map somewhere. Where's the map? This is not the map. The map is somewhere further down. Ah, yes, okay. So basically this particular thing it's something like Google Maps. What the code inside this particular notebook does is actually it does something very similar to Google Maps. It has all the data about where all the bus stops, all the roads, the entire train tracks, where all the train stations are. And the idea is to route between let's say if I'm going from point A to point B, it's supposed to be able to find a route to go from these two places. So that's what this particular code does. Of course, this is all just Python inside a notebook. Technically, I could also deploy this and put it inside, attach it to maybe Flask or something. Then it will also have a HTTP front. But inside here, yeah, it's just very good for me to just test out and make sure that the algorithm and everything is working correctly. Why exactly my internship, those guys, they got me to do this? I'm not sure, but yeah, it basically does what Google Maps does. Okay, so I have remade Google Maps. It took a while, but yeah, so that's one of the things that I did. Probably because when you're doing data science, you need all these routes. But when you're using the Google API, if you're using like the Google Maps API, there are limitations. Like if maybe they cap you to 5,000 requests a day. So sometimes it's better to have your own in-house algorithms and you know exactly what they do. So yeah, so this is one of the things that I developed before, and I did this all in. You edited everything within the browser itself. So that makes it very convenient. And if I want to share this with anyone, I can just just send this link. So I used to send this link to my boss. And then yeah, you'll just open it and see, okay, so this is what you did. I also use it sometimes, I will submit my homework within this itself. Yeah, so like sometimes some of the higher level business analytics modules, they want you to do like some analytics project. You basically need to get some data, analyze the data, do some graphs and whatever. I will do everything inside here, and then I'll just send the link to my professor. It's very convenient. Makes things a lot better than, if you have to like go and type a report inside, I don't know where lah, and then you have to take all your graphs and then you have to paste it inside there. Instead, this one puts it into a very viewable format, and actually you can add comments between as well. Like you see here, like you can actually put text within it. So yeah, this is one of the things that you can actually get a Docker container for. Where to get a Docker container? You can just Google it. I think it's called Jupyter Stacks. Yeah. So yeah, so this is actually just a container that you can get from here, and you deploy it. You get this entire Jupyter notebook, and you can just make use of it as and when you want. So okay, so some other things. Let's move on. How do I show this without it going back to the first slide? Oops. Damn it. Okay, open source routing machine. This one is actually another thing that is also similar to Google Maps, except that this one it uses OSM data. So it uses the OpenStreetMap data in order to generate routes. It's another tool that sometimes I also use if you are doing any kind of geospatial analytics. Yeah, this is one of the tools that you can possibly use. This one is of course the front end. This particular application, right? It actually comes in two parts. So there are two Docker containers. Actually, it's here. Okay, so this particular snippet is actually from the GitHub for open source routing machine. So you realize that there are actually two Docker containers here, right? Right. And then there is backend. Oh no, they have more than two containers. Okay, but okay, the two containers that you should need are basically the backend. The backend is where the HTTP API is located. So that is where you can basically send requests via curl or Python or whatever. You can send requests to it, and it will give you the route. Yeah, it will give you the route lah. And basically, it comes back in a JSON. Yeah. The front end, which is this thing over here, is deployed actually in another container. So when you deploy this application, you need to deploy both containers and then link them together. That's how it works. Some other things. This one is a little bit like, this is a bit like Dropbox. Nextcloud is actually a bit like Dropbox. So you can deploy your own Dropbox if you want and host your own files from your server. Or in a way, it's like a NAS, like network storage. Yeah. So this basically allows you to access your files easily from some web page, and you can just host it online. You can download any one of these files anywhere you want to go. Yeah, works very similar to Dropbox. I guess you will ask why we use this over Dropbox, right? Well, first of all, the space is completely up to you. So add as many hard drives as you want. That's one of the things. The other thing, of course, is privacy. I mean, if you're using services like Dropbox and all this kind of thing, you would think that they don't look at your files, which probably is true 99% of the time, but you don't know when, if let's say, I don't know, if you're putting illegal movies or something inside your Dropbox, yeah, then I guess they will be obliged to remove it lah. So if you want to host your files with more privacy, you can try one of these services, set up your own server. OnlyOffice is like Google Docs. So this is like this is actually made by some, if I remember, this is made by some Serbian company, which is quite interesting. But yeah, it was some Ulu country somewhere, and they somehow managed to make this entire Office suite. And this Office suite, if you read over here, it actually says combines the formatting quality of MS Office and online collaboration of Google Docs. So yeah, this is actually it's actually collaborative. So in that sense, you can do that whole, I type and you type, and we both can see what each other are typing kind of thing. There's also PowerPoint and Excel. There's also spreadsheets and presentations. So this is one of the things that you can also deploy. The whole Office suite that you can basically deploy on a server completely for free. This is okay. There's a free version. There's also a not so free version. So yeah. Okay, this one was actually a suggestion by Jin. He asked like, how do you host your music? If let's say I have some music on a server, right, and I want to listen to it from anywhere, one of the things one of the things that you can host using a Docker container, another piece of software that is available is actually this Apache, which you can host it. I've never tried this before, but yeah, I did find it. And so if anyone of you wants to, you ever have that thing where you want to listen to your music and you have it stored locally and you don't want to subscribe to Spotify and you don't like their advertisements, can use this. Of course, the legality of it is something else. So if you want to do this sort of thing, try to keep it private. I'm not going to comment what happens if you host these things and you leave it open to the entire open internet. Not sure what's going to happen. Never tried it before. Okay, Radar. This is actually, I thought this was quite interesting because this allows you to download movies and TV shows completely automatically. So you don't even have to like tell it, okay, go and find this torrent and whatever, and then get your torrent client to download it, right? Instead, now your torrent, your server is just going to torrent everything for you. You just need to tell it what movie you want. And so this is another interesting thing that you can try. Again, the legality of it is something else, but yeah. So you want to download movies, and then if you want to watch your movies, you can use this. It's Kodi. It's basically like this thing is actually like a whole media suite. So actually this also works for music. It allows you to host like an entire library of media. If you store a lot of media on your server, you can host one of these things. And yeah, it basically allows you to stream your movies from your computer anywhere. Again, especially for movies, don't leave it on the open internet, okay? Otherwise, you not only infringe your internet, your ISP's like terms and conditions, you're probably also breaking a lot of copyright laws. Well, you would have broken copyright laws anyway. It's just whether you do it privately or on the open internet, okay? So keep it private. Don't, or at most you can share with a few friends, but don't tell the whole world about it. So that's just some fun stuff that you can do. I'm not going to deploy any of these. Actually, yeah, I mean, I really should give you an example and try to deploy some of these on Docker. Ideally, I think it should just be a few commands, but sometimes you still need to do a bit of debugging, even though they give you very nice instructions, right? But unfortunately, my computer has run out of battery, so I'm not gonna try to do that. Yeah, okay, so this is just the last bit of it. Some advanced topics that I feel is like important if you want to do server deployment. Because when you do server deployment, when you become your own web administrator, at the end of the day, there are certain authorities and certain powers that you are entitled to, and there are certain things that you need to keep track of. Especially one of the things that I'm going to talk about here is security, and also some advanced things that you need to think about when you want to deploy your application, let's say across a few servers and something like that. So it's just some additional information that when you're deploying an application, I feel that these are the things that you should be thinking about. more than, what you're doing right now in doing the examples and all those, is kind of like, okay, so I just want to get it working, right? And I just want to try to get it working on one server. But when you eventually deploy an application, you are deploying it for many, many users. And if your application gets large enough, for those of you who are fortunate, if there are a lot of users, then eventually you're going to exceed the load of one server. And so at some point, you're going to have to think about how you're going to split this across multiple servers. So yeah, some of the things that I think you should consider when you eventually deploy an applications on a larger scale is like you need to have a very good handle on what your server load requirements are. That means like how many users you have, how much CPU is using, how much memory is using. These are things that eventually when you deploy your application, you need to have a very good knowledge of these how to say the requirements of the application. Otherwise, if let's say one day at some point you really exceed the requirements of your server and you exceed it before you expand your infrastructure, then you're going to end up with, your users are going to experience a lot of lag, or sometimes they will just have drop connections and all kinds of things, which is, of course, it's not good. I'm not going to cover all of this. So there's physical infrastructure reliability, network reliability. Those are things that, yeah, at some point you have to think about. Usually, you won't know this off the bat. You will hope that it is reliable, and then when it breaks, you will know that it's not. So, so yeah. So I mean, physical infrastructure reliability, I think just one of the things to note is, of course, when you deploy things on a server, make backups. Your database and everything, don't deploy once. You deploy a few times. If you actually care about your data, you deploy a few times and you save your data across a few hard drives, so that in case any of your infrastructure fails, especially hard drives or even now solid state drives, they also can fail. Yeah, just make sure that you have a backup of everything. Network reliability, I think in Singapore is pretty good, so we don't really have to talk about that. Planning for downtime. So downtime, okay, when I get to that slide, I'll get to that. Scalability and expansion flexibility, security, that's very important, and infrastructure costs is basically which service, be it AWS or DigitalOcean or whatever. So yeah, I'll talk about that in a moment. So application load. Okay, so yeah, like I was saying, right, I think one of the first things that you should do when you eventually deploy your application, you need to get a good handle on what are the loads on your network and also the loads on your server when you deploy it, to know whether or not your server is sufficient. If you deploy like the smallest droplet, droplet is a name for server on DigitalOcean. You deploy the smallest denominator, right? It actually has like 512 megabytes of RAM, not a lot of processing power. And in terms of like, they also limit the amount of network bandwidth that you are allocated. So you would want to get some idea of like how much CPU, how much memory is using. And you can do this using, I don't know whether you all know any application load testing kind of techniques, but you can do this by using curl. Curl is one of the methods. Basically, curl is like it's like you just send a request to the server via the HTTP API. Yeah. So that's basically what curl does. So once you set up your HTTP API, if you're using Meteor, you can't use curl because Meteor does not use HTTP at all. So yeah, if you're using Meteor, that's not going to work. But if you're using a more traditional kind of data stack, then curl is one of the things that you can use. Just repeatedly call your API and see how much server CPU it takes to respond. So yeah, so basically you monitor and then you load test. Another way that you can do this is you can do this using a script. This one will work for Meteor. So basically you get this thing called Selenium. Selenium is this library that allows you to control a browser programmatically. It's quite interesting. It allows you to, how to say, to script what you want to a browser to do. So in a way, when you actually start up Selenium and you make use of it, right, it looks it looks quite awesome on a computer because it looks like the computer is surfing the web by itself. Because you'll basically be like, Selenium, the way that it works is like you basically, okay, I want to find this button, then I click on it, then scroll around, maybe scroll to the bottom of the page, and then find this button, find this link, click on it, and then do something. And basically it allows you to script the entire thing. So the idea here is you want to script something that is going to emulate something that you think a user is going to do. And by doing that, if you start many of these and you instantiate it many times, you start many of these scripts, then likewise you can also go and monitor your server load based on it's sort of like user testing, but with fake users in that sense. So your users are simulated. This is a little bit better than using API calls, because when you do it this way, right, it means that you know which of the API calls are being used more often, which parts of your API is being used more frequently, and which parts of it are not, and which part maybe it takes a little bit more time to respond. You can also time the server response time, and so you know which ones are taking a little bit more time to respond and which ones are not. Yeah, so that's another tool that you can use. And of course, the other side of it is that you need to monitor your server. There are a lot of tools online that you can find, also usually packaged in Docker containers nowadays. One of them is Server Relic that you can deploy on your server, and then it basically monitors your server load and the network load, and it will give you this nice GUI that you can see everything from there, like your CPU load, your memory usage, and all this kind of thing. But of course, if you just want the simple method, you can just use stop. So you just go to your bash or whatever, you type in top, it will show you CPU usage. Okay, so downtime. There are usually two reasons for having downtime. And why is downtime important? I mean, right now when you're developing the application, probably it's not as important. But eventually when you deploy it, and if there are a lot of users and it becomes like kind of a critical application, you don't want to have that case where suddenly people start calling you out and like, hey, your application is not working, or this kind of thing, right? So you need to plan for downtime, and you want to keep your application up for as much of the time as possible to give it like maximum availability. It's not usually like a very critical requirement, but if you're developing applications that are more mission critical, like for example, if you're developing applications for a bank or for the military, for example, then downtime starts to become something that is very critical, and usually they will set requirements, contractual requirements on your application, like you have to keep it up 99.9% of the time, and you exceed this 99.9% of the time within a year, then we are going to fine you like a certain amount, this kind of thing. So at a higher level, there are these kinds of requirements, and you need to plan for downtime. So well, if you have failed physical infrastructure, there's not a lot you can do about that. You have to replace your infrastructure, and hopefully you have backups. But if you are talking about software updates is like the other reason why you might have downtime. Actually, Docker can help you with that. So what Docker allows you to do is you can actually deploy multiple versions of your application. So let's say you have a working version of your application, but now you have updated the code and you have a new version of your application. You can actually deploy them on the same infrastructure just to test the new version. So even while your previous version is running, right, you can deploy a new version alongside and test it on the same servers. Even if you just have one server, you can also do that. And you test it first, make sure that everything is working, do all the user testing, and maybe even if the new version has some features which were being requested by your clients, then yeah, you can also let the clients test the features even before they are deployed into the real version. So this is just like sort of like a example kind of workflow for doing a software update. So you build a new Docker image, you deploy that container, you test it, you test it first, you allow users to test it, do any debugging if necessary, change anything if necessary, and then finally you substitute the old container with the new one. And so this will allow you to do software testing, but with minimal downtime. In the past, before there was all these kind of things like Docker, right? Usually companies that need to do this kind of thing usually what they will do is they will have an entire dedicated testing server. Like they will just have one entire server rack which is dedicated just for testing the new version and making sure that everything is working before they finally deploy onto the real server. I mean, it's a little bit wasteful in that sense, because now on top of your main infrastructure which you are using to deploy your application, now you have this one entire server which is not being used very often, but once in a while you use it just to chuck your new version and test it and make sure that everything is working. And even sometimes, because this other server is not actually the same infrastructure, sometimes you test it on that other server, and then you put the container onto, or I mean not a container, but you bring your software over to your main server, and it still has some problems. Like for some reason there are like infrastructural differences between your testing server and your main server. So if you're using Docker, you can be sure that, okay, so if I run this on this server, definitely going to work. Okay, so another thing that when you're talking about using Docker, right, is that you can actually modularize your code by the functionality. So traditionally, what you always find is that the front end is going to be one code base, right? All your HTML, CSS, JS, whatever, is one code base. Your back end is one code base. Maybe you write it using Django, Flask, or whatever. It's one code base. You deploy it also in one container, and then finally you have your database, which is where you store all your data. But actually, when you're using Docker, right, you don't always have to think like that. There is actually some flexibility that you can employ. Like for example, if you find that when you look across applications, right, there are certain features which are actually common across all of these applications. Like for example, the login. Almost all the applications, if you want to authenticate who the user is, you're always going to deploy, like you're always going to be creating this login feature. So there's always this login screen. And unless you want to reprogram the login screen, or you want to I don't know, copy paste the code inside, it's a bit messy sometimes. This login screen, right, you can actually abstract it out, and so you deploy the login code all by itself in one server by itself. And so also, yeah, I mean, you can basically do this for multiple features. So for example, if your application has some microservices, some e-payment system, has some extended features, main features, you want to deploy analytics, yeah, you can actually break these down by features. And as long as these containers are able to talk to each other using the same protocol, like I don't know what protocol, it doesn't necessarily have to be HTTP. In fact, you can technically design your own protocol to determine how these containers are going to communicate with one another. But yeah, you can actually break these up by features, and it also makes it somewhat easier to develop, because now let's say you can just give a responsibility to one of the developers on the team and just say, okay, so you are just going to work on login, and that's all. And the end result that you're supposed to, the deliverable at the end of the day, deliver this one container that has all of these things, is able to log in, and then the output is just something in some protocol that tells, once it has authenticated, it tells the other app features what the user is. The other thing, of course, is that you can use, when you organize things this way, you don't have to use the same language throughout your entire application. I think for you guys, usually you are thinking like, oh, I use JavaScript for everything. That's great, right? It's easier when you start to use JavaScript for everything, because yeah, I mean, you only need to learn one language. But after a while, if you try a few languages, you realize that different languages are actually better for different things. So for example, JavaScript is usually very good for writing all of your front end stuff, typically. Like for all your, your button presses, it has all the callbacks. JavaScript is good at doing those things. Traditionally, people do not use JavaScript for servers, for server backends, but nowadays they also do. So because of Node.js. So yeah, now it is a possibility that you can use JavaScript on both front end and back end. But it used to be that your front end is usually JavaScript, and then your back end will be something else, like I don't know, Python, Django, some other, or even Java. Yeah, if you're really old school Java. And also analytics features. analytics features, usually they are easier to write in Python. JavaScript can be, if you try to write analytics features in JavaScript, sometimes it's a bit messy. So if you ever have face this kind of application where you need to write one application, but you need to split the features across different languages, yeah, actually you can also consider deploying it in such a manner. Okay, you notice here I actually wrote Docker in Swarm mode. This is actually a feature that I didn't really cover today, but the Docker engine actually is able to run across multiple servers. That's actually one of the more interesting features of Docker, but I presume that you guys are just going to be running on one server, so I didn't cover that. But actually, Docker can actually control an entire cluster. So it's like an entire cluster of servers, but you just have one Docker engine that sits on top of all of it. And then you just tell this Docker engine, okay, so I want you to run all of these containers. Oops. I just want you to run all of these containers. And the Docker engine is going to decide, like, based on your specifications, like how much CPU you want to allocate, how much memory you want to allocate to each container. It can actually then go ahead and distribute it across the servers that it's controlling. So that's actually one of the things that you can do with Docker, but you can, if you ever get to that point, you can figure out how to do that if you want to deploy it across multiple servers. Okay, so at this point, yeah, okay, I need to talk about security. You can't really have a server deployment talk without talking about security, because at the end of the day, you're going to be deploying things on the open internet. Even just now, we already deployed things on the open internet, like the when we deployed the website, that was already on the open internet. So anyone from anywhere in the world, if they actually, they type in the IP address, they can actually get access. They can already access that server on that port. So one of the things that is very important when you're talking about server deployment, of course, is to make sure that your server is secure. So here I'm just going to mention two security features which I think are the most important. Of course, there are many others, because when you're talking about security, if you just have one hacker that one day breaks into somewhere, bad things are going to happen. And when you're talking about server, it's like, if you talk about an analogy, it's like a house, and the SSH is like the front door. So obviously we're going to put the biggest lock on the front door, because this is where people normally walk in and out. But of course, there are always all the windows. You can talk about things like SQL exploits, all kinds of other things. But yeah, these are the two most important that I think you most definitely have to deploy on your server if you want it to be secure. So the first one is going to be public key encryption. You remember that you sent me your public keys. So yeah, you remember that you sent me your public keys, right? So this is where I explain to you, like, kind of like why it's important to use public keys, why I didn't just give you a password and say, okay, so this is how you access it, so just use this user and password and done. Even though that is a lot simpler, public key encryption is actually nowadays is not really just an extra security feature, it's a necessity. If you just use a password, almost all the time your server is going to get hacked at some point if you leave it 24/7. The other thing that I'm going to talk about is secure socket layer. Okay, talk about that when we get there. So basically, this is kind of like a simplified kind of explanation of how what the difference is between password-based authentication and public key authentication is. It all starts on the same point, actually. The client and server actually always establishes an encrypted connection between each other, and it always starts at this point. So even before anything starts, everything is actually already encrypted. So other people outside cannot actually immediately access this information so easily. It's not in plain text. The difference starts here when in password-based authentication, right? The server, the first thing it does is that it's basically going to ask the client, so what's the password? And then the client will encrypt the password to some hash, sends it back to the server. The server encrypts the password from that it has by itself, and then compares it against this. And if these two match, then access is granted. So this is how password-based authentication works. The thing is that the password is not unique to the session. So the password doesn't change. The password is there forever. It's the same every single time. And this encryption, right, even though it's technically is encrypted, right? But any client that talks to this server is also entitled to this encrypted connection already. So this encryption is actually not any security feature. It just prevents other computers who are along the way from reading the information. But actually, the encryption is not it's not going to make your server any more secure to attackers who are trying to gain access to your server via SSH. So the last thing that is protecting your server is actually the password. This encryption key is going to be known. The encryption function is known. The last thing that protects it is the password, and the password never changes. So nowadays, attackers normally all they have to do is they need to just brute force their password, and at some point they're going to get access to your server. Brute force basically means they just try everything, or maybe they try some passwords that they think are quite likely. And especially because normally when you deploy a server, you need the password needs to be humanly rememberable. Like you need to be able to remember this password, right? And so this password usually is of very limited length and complexity. Like it's not going to be very long. So yeah, it's susceptible to brute force attacks. But if you talk about public key authentication, where it's different actually is, okay, let me just run through this. So basically the client is going to send the ID, it's going to request that the server look for this ID first, which is basically the ID of the public key. So the server has this entire list of public keys, which, when you send to me all of your public keys, I put it on the server and it goes into this very long list that the server keeps hold of. It's going to look onto this server and check whether this public key is on the server. If the public key is actually on the server, then what the server is going to do is it's going to use the public key. It generates a random number. In this case, 1, 2, 3, 4, 5. You get some hash, and then it sends it back to the client. The next step is that the client is going to use the private key. So it's going to use a private key and a different hashing algorithm. It's going to reverse this to get back the 1, 2, 3, 4, 5. But of course, you don't want to send this 1, 2, 3, 4, 5 back directly to the server because, if, for example, the attackers actually know what the encryption key is, technically it's encrypted. But if an attacker knows what the encryption key is and they are able to sniff out this 1, 2, 3, 4, 5, then that's also it. Your server security is also gone. So what's actually going to happen is it's going to encrypt the 1, 2, 3, 4, 5, and yeah, it's gonna send it to the server back via a hash. The server will then encrypt this 1, 2, 3, 4, 5 and check whether this matches against that. And if it matches, then yeah, access is granted. So the difference here is that this random number, this random number over here, the password is actually a random number, which the server generates on the fly. It means on every single attempt, every single time you connect to the server, it's going to generate a random number. And so this random number actually it can repeat. So you can't even brute force a random number. The only way for you to attack this kind of encryption is if you try to get hold of this public key. So you have to be able to get hold of this public key and decrypt this number back into 1, 2, 3, 4, 5 so that you can respond to the server, and that's how you gain access if you're an attacker. Of course, I think you all saw your public key was like this. I don't know how long it is actually, but this incredibly long string of random hexadecimal. So it's not even hexadecimal for the matter. It's actually probably base 64. So yeah, the public key is very long. You can still brute force it. It's just gonna take a very, very long time, probably in the order of years or maybe even several decades on current day computers, depending on what kind of computer you're going to try to brute force it on. So yeah, so that will mitigate any kind of brute force attacks. And at the very least, it's going to keep your server a little bit more secure. I mean, just remember when you're deploying a server, you just need one hacker to figure out what the password is or what the public key of one of the clients is, and that's basically it. Okay, it's like from then on, the attacker can do anything. They can have all the access to all the data on the server. They can wipe everything if they want. They can even deploy funny things. They can put viruses, anything, and basically that's it. Once your front door is open anything can come in. So when you talk about security, you always need to be very careful about this, about what you're deploying. The other thing, of course, is secure socket layer. So the previous one is preventing people from gaining access to your server via SSH. This is protecting your front door, basically. Okay. The second one is actually the secure socket layer, which is, this one is for you to protect your users' information. So now when you put up your server on the internet and you deploy your applications on it, at some point, maybe, I don't know, if you're deploying like a e-commerce website or something, you're selling things. At some point, one of your users is going to send, for example, his credit card information maybe across the server. And when you're talking about this, right, you can never just use, it is never enough to just use the HTTP protocol alone, because that means that the HTTP protocol is completely unprotected. Any of the computers along the way, when I say along the way, I mean that, you know, when the client actually sends the let's say the credit card information over to the server, right, it actually goes across many computers along the way, many servers. So for example, it can go to the telco, and then maybe it jumps to, you know, a telco somewhere in a different country, and it jumps across a few servers, and then finally it ends up at the target server, right? And so it actually goes across many of these computers. And if you just send the credit card information in plain text, any one of these computers along the way has access and is able to read this information. And so you need to secure and encrypt these particular connections to make sure that anything that is being sent across this connection is not just completely open for everyone to read. So there, typically, you know, when you talk about client-server connections, usually there are two different kinds of attacks that the hackers usually make use of. One of them is called a man-in-the-middle attack, which basically means that one of the servers that is in between the client and the server, the information at the end of the day still gets to the server. But what the man in the middle can do is they can basically, you know, they can read the information, they can steal that information, they can alter that information, they can change it and say that, oh, you know, instead of maybe transferring $100, now you're transferring $500,000, and it goes to a different account. Yeah, so basically in between, the man in the middle basically can alter the messages that are going to the target server, and you no longer have a secure connection. You don't really know whether what is coming from the client is now the same thing that reaches the server, and you don't know whether the stuff that comes from the server, the replies, is actually what eventually reaches the client, because this guy over here now is able to modify and tamper around with the messages. The other kind of attack, of course, is a phishing attack, which is quite typical on the internet nowadays. So this kind of attack basically is where another server comes and stands between the client and the target server. But in this case, right, it doesn't even communicate with the target server. So your message never actually reaches the target server. Instead, all you're going to see is, like, you know, you go on the internet and you see it's just a fake site. It's completely fake. It looks like that one. It looks like this site. It has maybe it has a login, user, password, enter your credit card information here, and everything they can copy. Remember that, you know, when you host things on the internet, all of your HTML and JavaScript code, all of that is actually available for other people to just take. And so in a way, they can just take your entire website and rehost it, and someone else can host your website. And it looks exactly the same, except that the data never reaches you. Now it's going to go to someone else. And so if, let's say, you're buying something, and then, you know, if you key in your credit card information and then you send it across, you think that, you know, you're reaching this server, you send it here, and then that's it. And suddenly someone else has your credit card information and they can buy anything they want. So this is what you call a phishing attack. So at the end of the day, how does the client needs to know whether the target server is authentic. In the previous case, right, if you talk about SSH, the server needs to know whether the client is authentic. Now, in this case, the client needs to know whether the server is authentic. And this particular case is a lot more complicated. It's not as simple, because in this case, right, there is no way for you to say that, okay, so beforehand, whoever is running the server email the public key and then store it on the client, so the client is able to verify. There's no way to do that. The clients that the server is serving is actually completely unknown to the server beforehand. So the way that they come up with a solution for this actually is there's actually a third party involved, which is, they call it a certificate authority. So basically what happens here is that the server, right, actually, when you're setting up your server, you have to make a request to a certificate authority. You send them your public key first. So you send them your server's public key. And then the certificate authority is going to use your public key and is going to sign the certificate using their own private key, their so-called the root certificate key. And so they're going to sign this, and then they're going to come up with some certificate. So the certificate is now on this server. And so now whenever the client actually requests anything from this server, right, is going to be, first of all, the connection is going to be encrypted. And second of all, it's going to send across a certificate so that the client can verify that this server is actually the server that, you know, is who they claim to be. And who is making this verification? The third party, the certificate authority. The thing is that this is actually a partial solution, okay? The third party, technically, the certificate authority, technically can also go rogue. That means they can actually just say that, okay, so actually is this server, is not that one. And then now you believe that this server is the genuine one. And at the end of the day, the entire encryption breaks. So this is, honestly speaking, is just a partial solution. But at least, you know, if we are able to now trust this certificate authority, we don't have to store a database of every single target server's public key. Instead, now what all you need to do is you store a list of certificate authorities that you can trust. The certificate authority verifies that this server is legitimate. And by trusting this certificate authority, you can trust any of the servers that has this certificate authority signature on their certificate. So that's the basic idea. So when the client gets hold of the certificate, it verifies that, you know, the server that is on the certificate is actually this server, and that is done pretty much using the same private key public key architecture that was used for SSH. That's the first step. And then the second step is that the certificate also contains the name of the certificate authority. So it will verify that, okay, so this certificate was signed by this certificate authority. It's going to verify whether it trusts this certificate authority. And this list of trusted certificate authorities, right, is actually usually is packaged with the client. So it's your browser usually has this by itself. If you don't want to know what happens when you don't get a trusted certificate, sometimes the target server actually encrypts the connection, but the certificate is not trusted. So I don't know whether you all have ever seen it before. You know, if you're in Firefox, you get this big X and it says something like someone is trying to steal your credit card information, or something like this is not a safe part of the internet, blah blah blah. Yeah, the reason why you get that information is because the reason why you get that screen, right, that big red screen with a big X, is because the connection is encrypted, but it does not trust the certificate authority. So it's telling you that, okay, so you may want to check whether you trust this website or not. Yeah. So basically, when you use the secure socket layer, that is when you will get hold of your HTTPS. You know, this HTTP and HTTPS, right? Sometimes when you access a website, so let's say if you go to, say, IVLE or something, let's try it. Let's say you go to IVLE. Oh, or even GitHub. Yeah, even GitHub, you see that there's this HTTPS over here, right? This secure thing, it basically means that it's using the secure socket layer. And this particular part here, you notice that there's a green lock. This part means that it trusts the certificate authority. If you actually click this, I think you can. Can you see the certificate? Okay, I can't remember where to find the specific certificate for this website, but yeah, basically there's a certificate that's involved, and that is why you have this. So when you actually deploy any website, right, if if you're going to be transferring any kind of secure information like credit card information, all these kind of things, you need to pay attention to this. Because this part is actually part of the deployment process. I haven't shown it to you here today because it's a little bit complicated. But yeah, you need to figure out how to make a request to a certificate authority, get hold of this signed certificate, so that you can allow the clients to verify that your server is legitimate. And also at the same time, it encrypts your entire connection so that it's not just plain text being sent over the internet and anyone can read it. So it achieves two things in that sense: encryption and also client authentication. Right, let's go on. Okay, so the thing is that how do you know that these certificate authorities, right, they can technically just sign a certificate for any server, but you don't want them to do that. So these certificate authorities, right, usually there are like various companies around the world that run these things, and they distribute these certificates, and they undergo very heavy auditing by other companies, other tech companies like Microsoft, Google, whoever. They usually audit these companies. They will sort of do checks. I'm not sure what the exact process is, but they will do checks on these companies to ensure that the servers that they are authenticating are genuine. They are not like some untrusted phishing website that's like trying to steal credit card information, banking information, and all kinds of things. So these certificate authorities actually have to undergo auditing by other companies, and that's a lot of work, right? Costs money, right? So at the end of the day, you'll find that your certificates, if you ever want to get hold of one, they're actually very expensive. Yeah, one certificate can be like several $100s per year. Okay, compared to your cost of your server, which you'll later on find out is, I don't know what, $5 per month, comes out to about $60 a year for the minimum one, right? The certificate, if you want to keep your users' information secure, to buy one certificate, several $100s per year. Okay, there are actually websites out there that offer free certificates, but of course, you kind of want to question whether or not you trust these free certificates and whether or not they're trustworthy, So yeah, just something to take note of. If you want to deploy HTTPS, one of the things that you do, buy a certificate from one of these companies, and it's not gonna be cheap. So yeah. Personally, I have never bought anyone before. So far I have not had an application so critical that I need to buy one of these certificates. I have used the free ones before, because like let's say if I'm sending files over the internet, sometimes you want to secure the connection. I also do use that, but I use the free ones. The free ones are good if you are okay with them. You don't know which other kind of servers they authenticate, but since I'm just using the server myself, right? So yeah, usually if it's just one person, it doesn't affect too many people, then okay lah, you can use the free ones. But so actually for to just get some practice, you can try one of the free certificate authorities. I think one of them is, I can't remember what it's called, but I did see one yesterday. So yeah, just one of the things that you have to take note of. Okay, yeah, and finally we get to infrastructure cost, which is basically which service you're going to be deploying on. So I think some of y'all are asking, like, I gave you all this IP address, right? Where did it come from? It's actually hosted on DigitalOcean. When you talk about hosting a server where your physical infrastructure is, nowadays it's very convenient because you have all of these services out there. The two that I would recommend to you, DigitalOcean and Linode, they basically give you this blank Linux shell. So you go inside there and there's nothing on it. They will just give you the SSH access. You get into the server, you do whatever you want. Amazon AWS and Microsoft Azure usually is not as easy to set up. They usually have a lot of other things that you have to set up inside the web management console, but they are usually a little bit more application specific. So let's say if you are deploying some specific database, right? Instead of deploying the Docker containers directly, usually they will deploy some kind of virtualization, not Docker, but some kind of containerization on their end. but it's all managed through a web console, so you don't have to deal with any kind of command line. So I mean, if you just want to avoid command line, you try one of these. Amazon AWS, Azure. The other one is Heroku. You can also try that. Any one of the platform as a services you can actually try. Yeah, that's it. So that was the last slide. So any other questions, you can message me on Slack. And what time is it now? 3:10. Okay, so we're just nice. A little bit overshot. Okay. What? Right?
So just turn off the video.
What is it? Yes.